So, good morning, everybody. Warm welcome to Embedded World 2024 here in Nuremberg. My name is Axel Segura. I'm chairman of the conference and also speaker of the advisory board for Expo. It is my big honor to present the conference program and, of course, the keynotes for you. Embedded World is now in its 22nd year here in Nuremberg, with hitting all-time high numbers. All records up to now have been set. I mean, Embedded World has always been nicely growing. Then, of course, Corona led to a certain slowdown, but we are now in an all-time high for this year, and I hope everybody will feel this in the conference, in the aisles of the Expo, and in all the communication. In addition to what we are doing here in Nuremberg, you might have seen that we started to make Embedded World not only the contents world from software, hardware, AI, tools, IC, IP design, whatsoever, but also to make it global. So making it a world embedded worldwide, so to say. We had a first Shanghai edition in June last year. We'll go for another one in June this year. We'll also have a North America event in October in Austin. Making embedded world with a much larger footprint than it has been before. In all this context, we believe that, well, technology drives the world. Technology is an enabler to make the world a better place and hopefully also to make it a more peaceful place. One of the major drivers for technologies nowadays is certainly artificial intelligence. And especially from an embedded perspective, I believe this is extremely interesting to also see how AI, edge AI, distributed AI, federated learning, whatsoever, can be implemented. Because even though systems are becoming more and more powerful, they are still constrained devices. This is a nice challenge for engineers, obviously. Exactly around this topic, we'll have the first keynote of today, AI on the Edge, Unlocking the Potential of AI Applications, where the keynote speaker is, and we are very honored to have you here, is Dr. Salil Raje from AMD. Dr. Raje holds a Bachelor of Technology in Electrical Engineering from IIT Madras, and a Master of Science and doctorate degrees in Computer Science from Northwestern University. Has several patents in the fields of mostly EDA tools, also had been quite active in research topics and publishing research papers, but is now managing the AMD's Adaptive and Embedded Computing group, where he joined from Xilinx, where they take over the acquisition from Xilinx to AMD, took part in 2022. Dr. Salil, it's a great pleasure to have you, a great honor. Stage is yours.
Thank you, Dr. Segura. Good morning, everyone. Welcome to AI on the Edge and unlocking the potential of AI applications. We stand on the brink of an era where edge AI will reshape our world in profound ways. And we are just about uncovering the different opportunities that are ahead of us. Edge AI is going to absolutely change, and reshape our world now, but you can consider all of the innovations that are starting to roll out even already and setting the future up for astonishing advancements. In the world of industrial, all the innovations happening in training and inference is allowing industrial robots to learn and act autonomously, well beyond human programming. In healthcare, AI-based exoskeletons are making tremendous progress. So the convergence of robotics and AI is on the cusp of restoring lost limb functions for many individuals, dramatically improving their quality of life. So let's turn to auto. These AI assistants are on the verge of being introduced in your vehicles. And these AI assistants in the car will allow you to personalize your car, from adjusting settings to making dinner reservations to reading your user manuals, all while navigating the car. These AI assistants will fundamentally redefine convenience as we know it. Now, generative AI, such as ChatGPT, have captured the imagination unlike anything we have seen in the past 50 years and made AI relatable. But it is AI at the edge that will redefine how we interact with technology. Now, you may wonder why AI at the edge is important. Why not just depend on cloud and the compute infrastructures and move all the compute to the cloud? Well, there are at least 3 critical reasons why AI at the edge are extremely important. The first, most important reason has to do with real-time performance. Latency is an extremely critical factor in many of these edge applications, and connecting to the internet is not even an option. The second most important reason has to do with data security and privacy. So for that reason, the data has to reside at the edge or at the endpoint. And the third most important reason has to do with personalization. So training and inference that accounts for user preferences will allow you to customize your experience. Now, AI at the edge will grow when we can deliver performance, very high compute performance, within a constrained environment. And we believe that the places where it'll grow the fastest, at least in the near term, are markets and segments such as autonomous driving, infotainment services in a car, or anywhere really where there are like vision and sensor applications like robotics and so on. Now, as AI is moving to the edge and it's migrating to the edge, it's igniting a new requirement for decentralized intelligence, which means AI cannot depend on cloud and compute infrastructures. While at the same time, AI is moving forward at a very high rate to invent newer and newer models such as transformer models, large language models, or diffusion models that put tremendous pressure on compute. Multimodal transformers are creating new outputs from a variety of inputs such as images, text, video, and transforming autonomous driving, robotics, and healthcare imaging. Large language models such as Llama 2 and GPT are transforming video conferencing and other applications. And then there are stable diffusion models that are creating content such as images and video from text. And that's stretching the limits of our imagination. And these are being used in motion prediction and content creation. Now, these are just a few of the models being invented and being deployed. The world of AI is innovating at a very rapid pace and putting together more and more models and putting tremendous stress on compute. Now, harnessing the power of these continuously evolving models poses extreme challenges, especially because at edge, the constraints are quite severe. There are constraints on power, constraints on form factor, and other challenges. As AI moves to the edge, there are a whole host of new challenges, unlike anything we've seen in the cloud. And every application has a variety of constraints. You would think power consumption, latency, throughput, security, safety. And as each of these applications change and the algorithms change, these constraints and requirements continue to change. Now, there are infinite many use cases and applications that all of you here in the room are creating, and each one of these use cases and applications put different demands and different requirements on your edge applications. Developing at the edge needs creativity. If you remember the 3 applications I talked about, industrial, healthcare, and autonomous driving? Each one of them has different requirements. In industrial, for example, safety may be more important than power consumption. In healthcare, accuracy is non-negotiable. So you may want to do other trade-offs to get the accuracy up. And in autonomous driving, you have to trade off between latency and throughput under power constraints. Now, many of these applications have 10 to hundreds of TOPS of performance requirements with a power constraints of 5 to 50 watts with millisecond latency requirement. Now, imagine, if you will, your AI car is running on an autobahn at 200, 250 kilometers per hour, and it sees an obstacle at 50 meters. The AI needs to be able to apply a brake to the car within a second. So that's why latency is super critical in these applications. Now, these edge applications also need to be upgradable. You need to be able to update them, and sometimes even over the air, because the pace of AI innovation requires you to update these AI models into your edge application. So building an edge application with AI needs this system, all of these orchestra of systems to work together flawlessly. An AI edge application also needs a processing model that not only runs the AI inference, but also handles all the processing that goes around it. So there are typically 3 stages of processing that happens in an edge AI application. Stage 1 has to do with pre-processing. In this stage, it handles all the data that is coming in from cameras, LiDARs, radars, and does data ingestion and sensor fusion, and provides the system with information. The second stage is the AI inference stage, which uses pre-trained models, such as transformer models, large language models, takes the information provided by the first stage, and does inference and provides the system with analytics and perception. And the third stage is the post-processing stage, which actually takes the results of the AI inference and makes decisions, and then actuates the system. So you could be moving a robotic arm, or you could be applying a brake to the car. So having this whole application view, not just inference view, whole application view of the system is important to think about your design considerations as you build your edge AI application. Now, the very first consideration as you think about designing your edge AI application has to do with thinking at the system level. It's not just about inference, right? It's about the whole application. You have to think about all of the different tasks that go in the AI pipeline, and there are some tasks that are not even in the AI pipeline and have completely different purpose. So heterogeneous computing is very important as you think about your edge application. Now, these AI models and sensors and post-processing continue to change on you. So adaptability is the second consideration. Your products may want to be deployed at the low end as well as at the high end. So scalability is your third consideration. You need to be able to scale your platform across different market requirements. So scalability becomes extremely important as well. So let's now zoom into each one of these considerations individually. As I said, there are multitude of tasks that happen in an edge application, and no single processors such as FPGAs or CPUs or GPUs or NPUs, neural processing units, are the right task or right processing subsystem for all of the tasks, and they cannot run all of them flawlessly. So you need a heterogeneous computing approach. What that means is you need to be able to put together a system with different processing subsystems, different domain-specific processing subsystems, and assign the right tasks to the right processor and get your real-time performance constraints met, meeting all your other constraints as well. So that's heterogeneous computing. Let's talk about adaptive computing. Now, this term may not be as familiar to some of you. So let me explain what I mean by adaptive computing. As you know, in CPUs and GPUs, the hardware pipeline is fixed. So what that means is you can use the instructions in the instruction set for CPUs and GPUs, but you can't really change how the instruction is implemented. In adaptive computing, you can not only create your own instruction set, but you can actually customize how the instruction is implemented and pipelined to improve your memory accesses. A user can create the exact right pipeline for their application. Using adaptive computing, you can get significant performance benefits. Now, the performance benefits depend on the application. For some applications, you can get 10 to 100x better performance than, say, its implementation on a CPU. Now, additionally, because you can configure and reconfigure your adaptive device, you can take in the new specification as AI innovates and the pace of innovation is growing faster. You can take the new requirements and program them or configure the device with these new requirements. Adaptive computing will unlock AI performance. With adaptive computing, you can create the exact pipeline, hardware pipeline, customized pipeline for your, say, pre-processing stage or a post-processing stage. And knowing that you can reconfigure the device well into the future, even after deployment, will make you more resilient and allow you to get more longevity for your products. Because as AI innovates, you will be able to program in the new specification. Scalability is also important to address different environments. Scalability is important to ensure that you can meet your product as well as market requirements. You may have the need to have your product be deployed in the low end of the market as well as at the high end of the market. Your safety requirements, the number of sensors, the size of the AI models could all change depending on the market requirements. A car maker may want to deploy their product in the entry-level EV vehicle, but also would want to deploy their products in the high-end luxury vehicles, autonomous driving, cars and trucks as well. So ideally, you want the same platform to scale with software, tools, ecosystem, and certifications, so you reduce the amount of development effort and reduce the amount of time to validate, revalidate, requalify your products, improving your development cost. Now, these platforms, scalable platforms, need to come with a variety of devices, a large set of devices, so you can scale your market requirements using different devices. They need to be built on the same platform, the same architecture, and they need to come along with a strong ecosystem. Let's talk for a minute about software, using the example of auto. In automotive, as you can see, there are a variety of tasks in an automotive application. You can see that not all of these tasks can be handled by a single processor. So heterogeneous computing, as I said, is important. But it's not sufficient to assign each of these tasks to a different hardware processor. It's also critical that you have the right software strategy and right software stack for each of the tasks as well. These heterogeneous computing systems are becoming extremely complex. So getting performance from these systems means you have to rely actually on the software strategy to eke out performance. Your software strategy needs to account for a diverse set of operating systems, a diverse set of runtimes, and be able to assign the right operating system, the right runtime to the right tasks on the right processes. The software strategy is extremely important to fold in AI into your edge application. Now, a vibrant ecosystem is just as important to help you support you in your AI journey. When you choose a platform, you may want to think about a platform that comes with an ecosystem that is more responsible and more open. These platforms need to come with a variety of models so you can pick the right models and tweak them for your requirements. And an ecosystem needs to also come along with the right software tools and environment to make you productive. These three AMD ecosystem partners are making a huge difference in the world of AI. Hugging Face has tens of thousands of models, and you can use any of these models and be able to deploy them in your application. PyTorch is a framework that most people are using now, and it's making a huge difference to your productivity. But what's more important also is OpenAI Trident is allowing users to create vendor-agnostic models, and it's at the back end of PyTorch now. So you can create vendor-agnostic models and be able to transport them into different platforms and still get performance. AMD is working with these and many other ecosystem partners to support and contribute to this OpenAI ecosystem. Now let's get back to this whole application view of pre-processing, inference, and post-processing. AMD has the foundation in heterogeneous computing. With our CPUs, GPUs, FPGAs, our neural processing units, AI engines, and our processing subsystems for embedded, we are uniquely positioned to create a heterogeneous compute environment. With the Xilinx acquisition, we are also world leaders in adaptive computing. We have been working on this whole application acceleration, end-to-end application for edge AI applications for over a decade. We assign FPGAs to the pre-processing stage, a sensor fusion stage. You can assign the AI engines to the inference stage, and the embedded CPU subsystems for the post-processing stage. And together, we can meet the performance requirements under a very tight edge AI constraints. Now, this is present, so let me talk to you about the future. Extremely excited and proud to introduce to you AMD Versal AI Edge Series Gen 2. And this platform integrates end-to-end application, the whole AI edge application, into a single device. Thank you. Thank you. This is a true quintessential adaptive and heterogeneous computing platform. It comes with a whole host of domain-specific accelerators and processing engines. It comes with image signal processors, video encoders, decoders, video processing engines, AI engines, and the ARM-based CPU subsystems to put together the whole end-to-end application. You can assign the image signal processors and programmable logic to the pre-processing stage. You can assign the AI engines. These are the neural processing units. These are next-generation AI engines, get 3x TOPS per watt compared to our previous generation, to the AI inference stage. And you can assign the CPU subsystems, the ARM-based CPU subsystem, which have 10x better performance, scalar performance compared to a previous generation, to the post-processing stage. We also built in safety and security into this platform. So it supports ASIL-D, SIL-3, and post-quantum encryption. We optimize power through active power management and system monitoring. And given that the programmable logic and the AI engines are both adaptable, you can reconfigure these devices well into the future as you see newer requirements. This is truly a platform that comes with a variety of different devices, small, medium, large, that allows you to get scalability, that can go after many applications in many market segments. However, this is all abstract. So to make it all real, let me welcome to the stage Eiji Shibata, Executive Officer and Chief Digital Officer of Subaru, who will actually show you how Versal Gen 2 products are going to be used in a real-world use case.
Thank you, Salil. Thank you. Hi, good morning, everyone. I'm Eiji Shibata came from Subaru Japan, and I will introduce the implementation of AI Edge technology to the vehicle ADAS system. And AMD and Subaru have long partnerships that led to the current generation of Subaru's ADAS system, EyeSight. Already you know, EyeSight stereo camera is powered by AMD Zinc UltraScale Plus MPA SoC chips. This is very good device. And as we started to think about new SoC for the next generation EyeSight platform, and AMD new SoC captured our interest. And we spent many years to study AMD's new SoC with them. And now I'm excited to announcement that Subaru has adapted Basel AI Edge series Gen 2 for next generation EyeSight. And about ADAS applications, we are seeing state-of-the-art perception networks that is creating new outputs from many types of inputs. And this slide shows an example of perception model use case. This is internal of next generation EyeSight vision pipelines on Basel Ed Gen 2. And bottom one is the stereo vision input, 2 cameras. And next step, already you see the pre-processing AI engines and post-processing. And at first, next step, programmable logic can convert stereo vision inputs into a 3D point cloud data without costly LiDAR. And the next step, AI engines create the object detection and classification, segmentation, and driving path detection from these inputs. And Basel Ed Gen 2 have a customizable all-in-one single chip with post-processing and functional safety. This is a very useful and powerful chip we understand. And it is very good match for these types of vision pipelines. And you can see the next demonstration video. This is our prototype car. This test car have only the stereo vision system with no radar, no LiDAR, no digital map. Only the perception with the AI edge. And this test car has realized hands-off driving on snow surface, slippy general road. But please attention, this is a prototype car, not a production model. This is a potential of the AI edge technology. And we will continue to improve the ADAS performance toward to the production model with Basel AI Edge series Gen 2. And we need more support from AMDs. Thank you very much. Thank you.
Thank you, Shibata-san, and it's a huge honor for us to be entrusted with your central compute for your next generation eyesight.
Very exciting. Yeah.
We will definitely support you. But a question for you is, what challenges did you face as you integrated AI into your application?
Yeah. And we need the ultra low latency, the throughput on stereo vision pipeline. And actually, we have multiple AI algorithms running on the AI engine. And we need enough time to execute that algorithm. And multiple AI engines have to be able to run within a short time of window. And we managed the latency problem in-house. And we found this chip at Basel AI Edge Gen, series Gen 2. This is a very good match for our latency requirements. And I think we will improve the performance to match the latency problem.
Okay. Yeah. All right. Thank you.
One more.
Yeah.
I'm sorry. And Subaru's main objective for eyesight is to achieve our goals of zero fatal traffic accident in 2030. It's a very challengeable target, but it is not easy to solve. But we will continue to invest eyesight and AI technology to realize. And please continue to collaborate with us. Yeah.
Yeah. All right.
Thank you very much.
Shibata-san. All right. So as Shibata-san explained, the Basel Gen 2 products, he is using it in autonomous driving application. But this truly is a platform, and it's a scalable platform. It has adaptability. It is heterogeneous, and can truly be used across many other segments as well and many applications. And some of them I've listed here. It can go into healthcare, robotics, industrial, and so on. So in closing, I hope you realize that although the light shines very brightly today in AI in the cloud, it's really AI at the edge that'll redefine how we interact with technology and will reshape all of the industries around us. Now, as you consider the profound impact of integrating AI into your businesses or products, I hope you realize that it's not just about having a point solution, but it's about having a robust hardware and software platform. And I would encourage you to think about a platform that has heterogeneity, is adaptable and scalable, and a fusion of this platform of all of these three will propel all of us into this new intelligent, connected, and adaptive world. It is up to us at Embedded World and the embedded markets and people working in embedded to move AI to the edge. We are on this incredible journey together to make sure that we can make the impossible a reality. Thank you.